This video will be an absolute waste of time because all I'm gonna do is replicate what the translate node does. So these like rotate and scale, and I'm gonna also do the bend as well, the bend node. Here I just colored the box. I'm just gonna add some extra subdivisions, and let's put down a wrangle, and I'm gonna paste the code here so that you don't have to watch me type code for the next hour or so. So if you go to my ArtStation, you can just copy this code and then just paste it in here and expose the parameters. Now we have all this. So there's not, you can't see anything because you need to put the scale to 1. And now let me just put that there. Okay. So we can do a few things here. The translate, the same stuff that the translate node does, and the bend as well. Okay, so we can scale up whatever axis you want, and let's try to translate. Yeah, it works on the X, Y, and Z. We can rotate. So we've got a few options for rotations. So we've got the rotate before and rotate after. So now you can tell the difference. But if we move a bit on the translation, and now we try to rotate after, it's going to rotate after the translation. Might be useful, I don't know. And there's a third type of rotation using Quaternions. So if we define an axis, and now I could rotate around that axis. So this is a bit different from the other type of rotation because it's using an axis to rotate around that axis. Okay, and for the bend, let's define an axis, the top one, the y-axis, and the bend coordinate, and now we can bend. Doesn't matter how it was rotated, translated, scaled, because in the bending is happening before all these translations. If I were to do these translations before, then I bend, then it's gonna bend in weird ways, and I wouldn't be able to. Yeah, and there is also a ramp just so you could control where do you want the bending to happen, and we can just press reset all that, or just leave it, it doesn't matter. Okay. Okay, I don't know. Like, okay, I'll go into the code. There's a few things in here. Let me just open. This is better, so you could actually see what's happening. Okay, so at first I'm just defining a few variables. Yeah, never mind this. I'll get back to it later. And that. So these are the variables we need to actually control. You could see them when I expose. These are the parameters. Okay, first I'm gonna scale the thing. Okay, so these are not happening in order. I'm just defining a matrix, a scaling matrix, a rotating matrix, a translating matrix, rotation, some bend in here. I'll get back to this later. And the other type of rotation, this rotates around a centroid. So it finds the center of the object, then rotates around it. Okay, and here it's everything is happening in here. So it's this one line is all the transformations are being stored in one matrix, and then this matrix is multiplied by the position of each point in space, and this line is where all the transformations happen. Like everything up here, all of this is just defining matrices so that in the end we can just multiply all the transformations and they happen at once. So there's not a lot of calculations. Like in here, nothing is being written as this thing goes, like except for the bend. The bend is doing its own thing. Like you could forget about this for now. So this here, all of this until here. This is the only actual written where the wrangle is actually doing something. Everything before it is just defining matrices and telling, oh, this matrix should do this kind of like translation, just a little bit here, just a little bit there, rotate a bit here, and in the end, when I want it to happen, I multiply it by the point positions. Okay, I'm gonna bring back the bend. The bend is using, okay, I'll get to the bend in just a second, but I wanna talk about this line here. So everything I defined earlier with the scale, rotate, and all of that is being multiplied all at once inside a new matrix, matrix 2. They're all multiplied at once here, and the order matters. So if you multiply, let's say if you do the rotation first and you have the object rotated in a weird way and then you scale afterwards, then the scaling would squash or stretch the object. So you have to do the transformations in a certain order so that you don't get weird artifacts or transformations. The whole thing would be weird. Okay, so at first I'm just inverting whatever happened before. All the transformations I've done before. Let's say I moved it a bit. This invert would move the inverse, like it'll move the object backwards into the previous position. And now I'll scale. And this matrix 1, this is the rotation. Okay, so I scale, then I can rotate, then I'll apply the inverted transformation. So the thing that I removed, I'll apply it afterwards, and now I can rotate. This is the rotate after. This is why we can actually rotate around the axis. So rotate after, because the transformation happened, and now we're rotating afterwards. I think this is the one. That's the one. Sorry, because this is the translation. My bad. So this is the rotation before, this is the translation, and this is the rotation after. This X form, this is if you're using two of them. If you're using another node, okay, the bend will act weird if you, and the scale. Okay. So if you're using two of them, the X form, let me just, okay, before it's rotating around the previous axis, the angle it's gonna rotate around itself because it's always looking for its center, and the rotate after, as you know, it's gonna use this translate and rotate afterwards, but the rotate before is rotating around the previous axis, center axis or whatever, and the angle is rotating around itself. So I've got three types of transformations, rotations. It'll act weird with scaling, because there's no way if you scaled it before and you're trying to rotate after, it's gonna do this weird stretching, because I'm trying to do everything in one node, and it's I'm not sure if it's possible to fix that issue. Okay, so we can go back to here. Okay, so this whole thing now, I hope it's kind of clear. Okay, and in the end, I just set the new X form. So this X form, you can see it here. In the end, I'm just setting that, and I'm multiplying the extra transformation to it, this whole thing. So the X form, if it's not clear what's happening, I can add another. Yeah, okay, we have one here. If you could see what's happening here. Okay, everything, all the transformations, doesn't matter where it is, how big, how small it is, this will reset everything that happened, because everything is being stored inside the detail attribute, inside one big matrix. Geometry spreadsheet. Okay, so this is all the 16, the 4x4 matrix, and everything is being stored and inside the detail attribute. So in the end, if you probably don't need that. Okay. Yeah, so I just grab the detail attribute and I invert that transformation, and it will reset. So it doesn't matter where it is. You could keep doing stuff to it. Like I could keep changing, but nothing would change. The invert would invert it back to, because we're using the X form, everything that's happening here is always being stored inside the X form. And this also happens in the transform. You could actually expose the X form here and do the same type of, like if I scale it here and now I'll put that in here, it'll go back to, because we're using the X form. This X form is storing all the transformations inside a matrix, inside the detail attribute, and with that I can invert it if I wanna like reverse that transformation. Okay, so I've got so in the end I'm setting the new X form so I can keep track of it and redefine it later and tweak it however I want. Okay, let's go back here. So now we understand what this line was. I'm just grabbing the previous detail, and here this line is just confirming that there is one, and if there isn't one, I'm defining a new one using identity matrix. Identity matrix, it's like it's nothing. It's like one. If you So I've got this. This is a weird matrix. Okay. This is an identity matrix. So it's like multiplying by one. This is a 3x3 matrix. So we've got 3 here, 3 there, and these are responsible for the scaling. If I do 2x2x2, this box would grow this big, but in 3D, because you know this is 3x3. And let's go back. What else? So I've got first off the scaling. So as I said, if we scale this, that, and that, which are this, that, and that, so got let's say this is X, Y, Z, and go here, no, there. This is X, Y, Z, and then X, Y, Z. So the second one and the second one, come on, the second one and the second one, and the third one and the third one, yeah, there. So if we scale this, your object would actually scale. Like if we go here and do the scale, you need to visualize that. Okay, you need to scale, so you could actually scale the, yeah, so these are responsible for the scaling. And the rotation is, it's a bit tricky. It's not straightforward, because if you actually think about it, there is no actual rotation. Like it's a combination of sines and cosines that does the rotation. I can show you an example here. Oh, not that one. Let me. Okay, if I go to my blog, go down a bit, should be somewhere here. Okay, so if you see here, we're not actually rotating. You can actually rotate. All you can do is squash and stretch in certain ways, and then you would have an illusion of rotation. Okay, I hope that is somewhat clear. So with sines and cosines, you could do this, and I did it in two ways. So there's this combination of sines and cosines, and there's another one right here, and I used two techniques to do that. And if you're wondering where did I even come up with all this combination, so if you could just go here, and it's all there. Like it's all in Wikipedia. You can find it literally anywhere. Yeah, so you just literally just copy and paste these values, like in the correct order, like, and depending on how Houdini likes it, the VEX code or any other code, doesn't matter. You could just put it in here and it should work. This is the translation. So in Houdini, the translation is happening on this, that, and that. Oh no, okay. These are the scale. So they stay one, and here's the translation. It's happening in the end. Okay, so this is a 4x4 matrix. So this is matrix 3. All the rotations are matrix 3, but the translation is a matrix 4. And in Houdini, matrix 4 is just matrix, because there is no more than matrix 4 in Houdini. Like, you can't go above that. It's 4x4 and that's it. Yeah, let me. Okay, so I've got this 4x4 matrix. In Houdini, this part is responsible for the translation. And in some other programs, I think it might be this part, but in Houdini, it's this X, Y, Z. And this number here is either 0 or 1. I'm not sure what to do with this. I need to look into that. But yeah, all you need is here. And in the end, this is X, Y, Z. And now we can actually translate the X, Z, and Y, all of that. Okay. The rotation, this is just the other type of rotation. This part. And for the third and final type of rotation, it's I'm using a rotate function, and it takes 3 arguments: an angle, an axis, and the actual matrix. So this is I just defined a new matrix, an identity matrix, and this rotates this matrix along that axis with that amount of angle. So this, imagine an abstract new matrix that doesn't have anything to do with anything, but it's rotated around an axis. And when this happens, imagine this virtual thing that is it's like an instruction of rotate around an axis. This is the instruction, and afterwards you take it and you multiply it by the other matrix, and in the end it's applied to the position. So this notion of rotation is applied here in the end, but defined in an abstract virtual thing that is not actually there. Okay, finally, bend. Okay, so we first I need to define the minimum and maximum values of. I need to know how big the object is so that I can twist it the way I want to twist it. So this whole thing is, this bend is a rotation, but it's using a gradient to rotate. If I go here, you could see there's a gradient along the y-axis, and afterwards I could rotate, but it rotates more when it's where it's white, but that's not quite right. Yeah, depending on the ramp, but it's generally using this ramp like from 0 to 1, and to know which way it needs to apply more or less rotation. So this part here is I'm just getting the minimum and maximum values, and the if statement is this whole thing is just defining which axis I want to bend according to. All it is we're just multiplying this angle by a ramp and a gradient, and the quaternion would do the rest. You would define a quaternion the same way we were defining matrices before, and the qrotate applies this transformation or rotation to the point positions, and in the end everything is stored in the X form so that we could use it and reuse it later. And that's pretty much it. I think that's all. Yeah, we've done all of this so that we can replicate this transformation node. Yay.